Okay, so exam 2 is on this coming Friday. So it's available all day, and you have 3 hours to complete the exam. Um, we also decided to reopen all the homework on webwork, and then so that means you can access the homework and then you can do them for full credit. And the homework, all of them will be due on April 27. I haven't decided when to put um, what the deadlines for the last 3 homeworks yet, but I'll send out another email about this later today. Um, yeah. So the idea is, as I mentioned in one of my previous emails, we have two alternative grading scales, basically putting more weights on the homework. In I think in one of them the homework is worth 40%, and the other one the homework is worth 50%. So you should think of this as a good thing. Um, if you miss any on the of the homework, make sure to do them for credits. There's no class on this Friday. Any questions? Any questions? No?
I won't, but like, ooh, I think
Okay. All right, let's continue. Let's finish up the example that we studied last time. So um, this is the exam 2 from last semester. Question 6. Okay, so you're given the function f of x, and then you're given the derivative and also the second derivative. And we mentioned last time that the domain for the original function f of x was everything but 1. And then we also finished the second part. Um, let me think. The horizontal asymptote. Actually, the vertical asymptote. The vertical asymptote is x equals 1. Horizontal, there's no horizontal asymptote. And then we discussed last time that the slant asymptote is y equals x plus 1. Let's move on to part C. So any questions so far? So this is what we did on Monday. Okay. So part C and part D. Identify the intervals over which f of x is increasing or decreasing, and identify all the points um, where f of x attains its local max or min. So which function should I be looking at? So how do I find increasing, decreasing, local max, and local min? Mm-hmm. What do I do? So look at the first derivative. What do I do? Okay, so you want to find all the critical points. Yeah, so critical points are the points where the derivative is 0 or undefined. Does it have any undefined points? Does the derivative have any undefined points? Okay, well, yeah, x equals 1 is an undefined point, but because it's not in the domain, we wouldn't say that's an that's a critical point. Does it make sense? So technically, x equals 1 is a critical is an undefined point, but because it's not in the domain, we won't say that it's a critical point. So there's no critical point, no undefined point in the domain. Make sense? So that means I only need to look at the first derivative equals 0. Wait, what am I doing? Okay, so it's that x and x times x minus 2 divided by x minus 1 square equals 0. And the only way for a fraction to be 0 is when the top is 0. So x times x minus 2 equals 0, which means x equals 0 or x equals 2. So those are your critical points. And what do we do next? Okay, so draw a chart using the first derivative. So use the critical points to split your domain, which should be something like this. Uh-oh. Guess I'll continue. So the domain was negative infinity to 1 and then 1 to infinity. So using 0 and 2 to split the domain, you should get something like this. Does it make sense? You have to look at the domain, Daniel. Does it make sense to everyone? Does it make sense that I'm writing, so for this part, I'm writing 0 to 1, 1 to 2 instead of 0 to 2? Yep. So this is actually a very good example, because so what could happen is it could happen that f prime is positive from 0 to 1 and negative from 1 to 2. So if you do from 0 to 2, you wouldn't detect the difference here. Am I making sense? So I'm saying that it would be a big mistake if you don't split your interval like this. So 1 is not in the domain, so you have to split the domain like this. And then pick points from intervals and then plug into your derivative. So from negative infinity to 0, pick a point and then plug into the first derivative. So let's say we pick negative 5. Is it positive or negative? Is the derivative positive or negative? Positive. So the derivative was x times x minus 2 divided by x minus 1 squared. So if you plug negative 5, it's positive. And then you do the same for 0 to 1. What is it? So you can pick 1/2, positive or negative. Mm-hmm. Negative. Do the same for 1 to 2. I think this one should be negative as well. This one should be 0. And then last one would be positive. So the function is increasing on this region, decreasing on this region, decreasing on this region, increasing again on this region. So it's increasing from negative infinity to 0, and then 2 to infinity. Decreasing from 0 to 1, 1 to 2. And we also know from the chart that the local max should be x equals 0. So part D is asking local max and local min in terms of x and y coordinates. We know that the x coordinate for the local max should be 0, right? And how do I get a y coordinate? Okay, plug x equals 0 into the original function. The original function was x squared divided by x minus 1. So when you plug 0, you get 0. Local mean occurs at x equals 2. So the x coordinate is 2. And to get the y coordinate, again, you plug that into the original function. That gives you 4. Questions? Okay. So what I did was I used the first derivative and then to find increasing, decreasing, and then to check which one is local max, which one is local min. So what is the second method for checking if a critical point is a local max or min? So what's the second method for checking that 0 is a local max and 2 is a local min? Hmm. Did I mention that the exam is only 3 hours? So it's available 24 hours, but you can only do that for 3 hours. That means you don't have the whole day to do the exam. That means you have to prepare for the exam in advance. And I'm very worried about that right now because I'm asking a very simple question. So what is the second method for verifying that 0, 0 is a local max and 2 and 4 is a local min? Okay, you look at the second derivative. How do I know, for example, how do I know 0, 0 is a local max using the second derivative? So I guess I should call this a practice. Use second derivative to check I guess to verify this. Okay, if the slope is 0, then all right, I'll let you check that. Any other questions? All right, so we have solved questions on part C and part D. So let's move on to part E. Part E and part F. No, actually part E. So identify the intervals over which f of x is concave up or down. So any ideas? Okay, so you look at the second derivative to find. You look at the second derivative and then find the inflection points. Okay, so second derivative is 2 over x minus 1 over 3. X minus 1 to the third. And so how do I find inflection points? Okay, so set it to be 0 or undefined. Does it have any undefined points? Nope. So x equals 1 was the only undefined point, but it's not in the domain, so we wouldn't say it's an undefined point. And so that means I only need to check 2 over this guy is 0. So 2 over x minus 1 cubed equals 0. How do I solve for x? Any ideas? 2 over x minus 1 cubed. Okay. So in general, for a fraction to be zero, the only way for a fraction to be zero is when the top is zero. But the top is a number too. It can never be zero. So what does it say? What does it mean? Concavity does not exist. What does it mean? Does it mean that it's never concave up and it's never concave down? I mean, a function has to be concave up or concave down. It cannot be neither. So I'm asking, solving this equation. So solving this question, the equation tells you that there's no solution, and no solution to this equation means what? No. So when we say the first derivative test and also the second derivative test, we say that for finding local max and local min. This question is not about local max and local min. So okay, so if there's no 0 or no undefined point, that just means there's no inflection point. And now that means we only need to check second derivative for these two intervals. So the domain was from -infinity to 1 and then 1 to infinity. And pick points from the intervals and then plug them into a second derivative. I'll let you check. So for example, if you pick 0, you're gonna get negative. And if you pick 5, it's gonna be positive. So that means the original function was concave. The original function is concave down here and then concave up here. Make sense? Questions? All right. Part F. So using the information that we discussed, the last part is about sketching the curve. So what do I do? So what would you do? Probably no, but as I mentioned, you could get matching questions. So potentially you would get multiple graphs to choose from. Okay, so draw the vertical asymptote and also the slant asymptote. The vertical asymptote was x equals 1. The slant asymptote was x equals x plus 1. So x equals 1 is here. So this would be my vertical asymptote. And then y equals x plus 1. It's a diagonal line that looks like this. So it passes through 1 and -1 here. And I also know that my local max is 0, 0, and local min is 2, 4. So 2, 4 is here. This one is 2, 4. And then this one is 0, 0. By the way, how do I know this point, 2, 4, lies above the diagonal line? How do I know it's not below the line? Okay, no one to want to answer me, so I don't want to answer my question. All right, so 0, 0 is a local max, and 2, 4 is a local min. And I also know that, what do I know? I also know that from from negative infinity to 1, that's concave down. So it should look like this. And from 1 to infinity, it's concave up. So it looks like this. And you can check that. You can check that this also agree with what we found for increasing and decreasing. So increasing from negative infinity to 0, and that's correct. And 2 to infinity, that's correct as well. So negative infinity to 0, and then 2 to infinity. And it's decreasing from 0 to 1, and then 1 to 2. That's also correct. Make sense? Any questions? All right. So on the same exam, let's look at some antiderivative question. So let's do question 2. Okay, so you have the interval from 1 to 4 of 3q plus root t over t squared. The first step is split the function into 2 parts, like this. For the first term, t cubed divided by t squared, that's just t. For the second term, what do I do? Yep, so root t is t to the 1/2. So t to the 1/2 divided by t squared, that's t to the 1/2 minus 2, which is negative 3/2. Is it okay? Now you find the antiderivative. So what is the antiderivative of t, and what is the antiderivative of t to the negative 3/2? Any ideas? Wait, what? What is the antiderivative of t? What is the function so that when you take the derivative, you get t? Yep, it's 1/2 times t squared plus, I guess this is 1/2, -3/2 plus 1. This should be -1/2, and so -1/2 as well. Evaluate that at 1 and 4. So then this notation means that you need to plug in 4 and then plug in 1 and subtract. Is it okay? I'll let you finish this. The rest should be easy. Question 3. Consider the function capital F of x equals the integral from cosine of x to 1 of 5 minus t squared dt. What is the derivative of that? So what do I do? Okay, so the lower limit is cosine of x, the upper limit is 1. Oh, by the way, so what theorem are we going to use for this question? Yeah, you're going to use the fundamental theorem of calculus at some point. But before doing that, you have to make sure the lower limit is a constant and the upper limit is a function in terms of x. So that's why we need to flip the lower and upper limits. So when you flip 1 and cosine, you get a negative sign like this. So that means when I take the derivative, what do I get? So you get -5 minus something squared times something. So what is the first something? Yep. And for the second something? Yep, so the second one would be the derivative of cosine of x. And this is by the fundamental theorem of calculus plus chain rule. And yeah, I probably should finish that. So this one will be 5 minus cosine x squared times, what is the derivative of cosine of x? Negative sine of x. That's it. Questions? No? All right, so to make you feel worse, let's look at question 17. Okay, so this is a graph for f of t. It's formed by two adjacent semicircles of radius 1. Consider the function g of x defined by the integral from 0 to x when x goes to 0 to 4. First part, calculate g of 0, g of 1, g of 2, g of 3, and g of 4. Any ideas? Okay, so what is g of 0? So when I put in 0, I get lower limit is always 0, and then the upper limit is 0 in this case. So what is the integral of f of t from 0 to 0? So what happens when the lower limit and the upper limit are the same? So lower limit and upper limit, if the lower limit and upper limit are the same, then the integral will become 0. What about g1? So this is the integral from 0 to 1 of f of t. What is it? Okay. No, but I'm curious how you guys got 1 or 0. By the way, what is the what does so for example, what does g1 represent in terms of the graph? So you're told that f of t is made up of two semicircle. One is above the graph. The second one is below the graph. And then we also know from previous discussion that the integral is basically the same as no. This is the same as the area under the graph of apple bags from 0 to 1. That's why you need semicircles. So what is the area of the graph from 0 to 1? Pi over 4. So it's a quarter of a circle of radius 1. It's just pi r squared, but the radius is 1 divided by 4 because it's only a quarter of a circle. Make sense? So this is g of 1. What about g of 2? So this is the area under the graph from 0 to 2. It's again pi r squared, but because it's a semicircle, so divided by 2. So this one should be pi over 2. Am I making sense? G of 3? So you get the first semicircle, and then you also get a quarter circle below the x. No. So G of 3 would be so for G of 3, it would be this. Right? So you have two pieces. One is above x, one is below x. And then the integral is the same as computing the area above x minus the area below x. So the area above x is this piece right here, the first semicircle, which is pi over 2. The second piece of the area should be, it's a quarter of a semicircle, so it's pi over 4. So pi over 2 minus pi over 4, which is pi over 4. What about G of 4? G of 4 is 0. Why is it? Yep. So for G of 4, you're looking at two semicircles, one above x and one below x. Because they have the same area, which is pi over 2, so you do pi over 2 minus pi over 2, which is 0. Questions? Great. Part B. List all the critical points of G of x and determine which one is the local min, which one is the local max for the function g. So remember that the G of x is this guy. How do I find critical points? Why? So we're talking about G of x, and I'm asking how do I find critical points of G of x? Yep, so you take the derivative of G of x. So G prime of x. What is G prime of x? No. What is G prime of x? G prime of x is f of x. Why is it? By what theorem? The fundamental theorem of calculus. So G prime of x is f of x, and I want to find the critical points of G of x. So I need to set the first derivative to be 0. So set it to be 0. Now, what are the points where f of x is 0? Two and 4, and 0. So critical points. X equals 0, 2, and 4. Which one is the local max? Which one is the local min? So for x equals 0, is it a local max or is it a local min? 0 is a local max, and why is it? Okay, x equals 0 is actually a local min. Simply because when you plug in 0 into the function g of x, you get 0. But when you get past 0, g of x increases, right? That's what we computed earlier. So g of 0 was 0. So g of 0 was 0, and g of 1 is pi over 4, which is positive. G of 2 is pi over 2, which is again positive. So it's actually increasing from 0 to 2, which makes x equals 0 a local min. What about x equals 2? It's a local max. So the derivative to the left is positive. The derivative to the right is negative, which makes x equals to a local max. And you can check that x equals 4 is also a local min. Is it okay? Part C. Where is the global max? 2. Yep. So global max happens when x equals 2. That's because, so one way to look at this is to look at the area. So we computed g of 0 is 0, g of 1 was pi over 4, and g of 2 was pi over 2. When you get past 2, the area will decrease because you need to subtract the part of the region that's going to be below x. Make sense? So g of 2 is the global max here. Part D, inflection points. So what are the inflection points of g of x? So we mentioned last time that inflection points of g of x would be the same as local max or min of g prime of x, which in this case is f of x. This is by the fundamental theorem of calculus that we used earlier. So what is the local max or local min of f of x? I'm asking what are the local max and local min of f of x? You already have the graph of f of x, right? What's a local max and what's a local min? If I give you the graph, how do I know where is the local max and where is the local min? Yep, 1 and 3. Last part. Sketch g of x. So I know that 1 and 3 are inflection points. I also know that 2 is a global max. And I know that when x equals 0, g of x is 0. When x equals 1, um, it's pi over 4. When x equals 2, it's pi over 2. When x equals 3, it goes down to pi over 4. When x equals 4, it comes down to 0. So now what? I know that 1 and 3 are inflection points, so it would have to be concave up and concave down on different sides of 1 and 3. So to the left of 1, is the function g of x increasing or decreasing? Sorry, is it concave up or concave down? Um, I'm asking for g of x, not f of x. So concave up and concave down have to do with the second derivative. So you're looking at the second derivative of g of x. But the second derivative of g of x is the first derivative of f of x, right? Now, if you go back to the graph of f of x, what is f prime of x in terms of the graph? Okay, f prime of x in terms of the graph is the slope. Between 0 and 1, is the slope positive or negative? So in the graph f of x, between 0 and 1, the slope is positive. That means the function g of x is concave up because the second derivative is positive now. I'll let you check. Between 1 and 2, the first derivative, f prime of x should be negative, which means the second derivative of g should be positive, should be negative, so it's concave down. Between 2 and 3, first derivative is negative, that means the second derivative of g should be negative as well. And then this one is positive. I'll just write it here. So g prime is positive here, g prime is negative here, double prime is negative, double prime is positive. Questions? All right, so I've already taken your attendance, so you're free to leave. I'm gonna stay for a minute for those that have any questions. So let me know if you have any questions.